This split screen shows a stable, traditional analytics dashboard on the left and a chaotic server log on the right. The top-of-funnel drop-off is invisible to standard tracking because autonomous AI agents are extracting data without executing client-side JavaScript, bypassing your analytics entirely. The industry often labels this AI SEO. Reader digests it easily inside a chat interface. That is a solved problem. Agentic SEO is the architectural practice of optimizing your website strictly for an autonomous machine executing deterministic data extractions. If you fail to architect your site for this unseen machine interaction, your brand vanishes from the autonomous purchasing pipelines dictating future search. When an AI crawler requests your URL, it does not read the page. It executes a strict sequential parsing process that takes roughly 300 milliseconds. At every stage of this 300 millisecond sequence, the agent evaluates the data it finds and continuously updates an aggregated mathematical score. We call this exact chronological sequence the agent confidence pipeline. The stakes here are absolute. If the final aggregated confidence score falls below the agent's pre-programmed threshold, your data is dropped. There is no manual review, and there are no second chances. Surviving that split-second window requires abandoning human-first UX design and restructuring your page as a direct machine-to-machine data delivery system. The pipeline begins in the first 50 milliseconds, the DOM parse. The moment the agent connects, it strips away your entire visual layer, exposing the raw HTML architecture. This exposes the primary failure. Heavily nested div tags give the machine zero structural meaning. Without semantic meaning, the parser cannot distinguish a product table from a footer link. The correct approach uses strict semantic HTML tags like main, article, and aside. These specific tags provide the immediate structural map the agent needs to locate extractable information. A clean, semantic DOM architecture is the prerequisite. Without it, the agent will never even attempt to extract your factual data. From 50 to 150 milliseconds, the pipeline moves into the structured data extraction phase. Many engineering teams assume that passing Google's rich results schema validator guarantees an AI agent will trust the data. Google uses a pass-fail system. AI agents use probabilistic evaluation. A sparse schema block passes Google, but the agent parser gives it a failing confidence score. Injecting availability and aggregate ratings gives the machine intersecting vectors to verify the claim. Data density drives confidence. For maximum machine trust, prioritize 5 specific schema formats: product, organization, FAQ, how-to, and article markup featuring explicit authorship. Standard validation tools only confirm your syntax is legal. They do not prove your data is robust enough for an autonomous agent to act upon. The pipeline now enters the 150 to 250 millisecond window, entity resolution. Listing a brand name as simple text forces the agent to treat it as ambiguous. A string could be a company, person, or error. The machine responds by applying a trust penalty. The architectural solution to ambiguity is entity chaining. Entity chaining utilizes the same as parameter inside your JSON LD block to establish an irrefutable connection. You point that parameter directly to established external knowledge graph anchors, specifically Wikidata QIDs or Wikipedia URLs. Wiring your local data directly into a verified global database removes the machine's need to guess. The algorithmic result of that cross-referencing is immediate certainty. Entity chaining is the exact mechanism that converts a vulnerable text claim into a mathematically proven, highly trusted asset. We reach the final 50 milliseconds of the pipeline: confidence score assignment and output formatting. The inclusion threshold is a ruthless binary. If the accumulated score across the pipeline falls short, the page is dropped. Even if a page passes the threshold, the physical formatting of the text dictates the result. This layout comparison demonstrates why. On the left, dense human prose forces the agent to summarize, introducing error. On the right, an agent-optimized block allows the machine to quote perfectly. To guarantee extraction, answer questions immediately with declarative sentences. Place specific, quantifiable data like cycle ranges or timeframes at the very top of the section. Formatting for direct machine-readable extraction is your final defense against an agent misinterpreting verified data and selecting a competitor. To serve this new tier of traffic, teams must pivot away from the single web page and optimize at the broader server infrastructure level. The immediate action item for every engineering team is an audit of the robots.txt file. In 2023, organizations placed blanket blocks on GPTbot, ClaudeBot, and PerplexityBot to prevent data scraping. Today, those exact blocks actively prevent those same agents from surfacing your brand in autonomous search. Traditional web analytics are useless here. As this terminal execution shows, the only way to track this audience is through direct server log monitoring. Tracking these specific crawler hits, measuring RSS hit rates, and monitoring manual brand mentions are now the only reliable indicators of agentic visibility. The ultimate architectural evolution is to bypass the HTML pipeline entirely by exposing a public GraphQL or REST API that feeds pre-structured JSON directly to the agents. Achieving top-of-funnel visibility is no longer a front-end marketing endeavor. It is a strict server-side engineering task. The vast majority of enterprise websites are currently completely invisible to these agents because the web was built exclusively for human eyes. Bridging the gap to an agent-optimized architecture requires a total reevaluation of who your primary visitor actually is. The machines are already making decisions at scale, operating in milliseconds, entirely beneath the visible layer of the web. The businesses that successfully restructure their data for the machine today will completely capture the autonomous purchasing pipelines of tomorrow.